Hello and good day, geometry. I'm not even on the right page here. We are wrapping up our unit on triangle characteristics with CO32 with something called the Hinge theorem. And the Hinge theorem kind of falls in line with the triangle inequality theorem. And then it's used to think about the varying side lengths of triangles. And so yours is not in color, mine is, so you kind of have to use some imagination with yours. Yes.
What about buttons?
I do have a button bar. When the time is right, they will be used. Okay. I've not memorized them fully, but I've done pretty good job.
Joe, can you click them without the mouse?
I've used my finger, yes.
Yeah, can you do it?
Yes.
What's a button?
You
You
just
just all of them?
3, 2, 1, you are quiet. So, the 3 red segments are all congruent, okay? And the 3 green segments are all congruent. Now, since you don't have green and red on your page, what I'd like you to do is take your pen or pencil and mark them congruent, okay? So that we have that out of the way. Damien.
Why do you have a button bar?
I'm always looking for ways to, add to my teaching, add the math experience.
What's it for?
Oh, they make different sounds.
Chris
got
someone.
Wait, can the people here, like the people are listening to the video here?
Yeah,
Can you click them? I don't know what they do.
Yeah, when the time is right.
Take the time right now.
3, 2,
Click it.
1. So what this shows you is that you can make 3 very different triangles when you have 2 congruent sides. Okay, the red segment congruent in all of them, the green one congruent in all of them. But what determines that length of that third side, which is dotted there, is the measure of the angle between our 2 congruent sides. Right? And so this is called the Hinge theorem because you think of like the door to a gate, right? As you swing that door open, what happens?
It opens.
The gate opens. The amount of space you have to walk through gets larger, right? Not only that, but the angle from which the gate separates from when it's in a closed position gets larger. You think about this gate in this position versus that one versus almost all the way open. Not only does that opening increase, or that third side gets longer, but the angle in between your congruent sides also gets larger. Until you open it all the way, and you've got just it's flat, and you've got all green patches for it. See why it's called the Hinge theorem? Isn't that clever, boys? Okay. So what do you notice about the dotted side and arced angle of each triangle? We kind of already said it, but to summarize, as the angle increases in measure, the third side will increase in measure as well. Okay? And that pretty much sums up the Hinge theorem. Right? As the angle increases, Damien?
Yeah.
Can you handle holding a water bottle?
He was making you want to press the button.
Okay. As the angle gets larger, the third side gets longer. Okay? As the angle gets larger, the third side gets longer. That's a horrible longer. Longer. The third side is represented by that dotted line there, the non-congruent side. Okay? There's a direct relationship between that angle in between the congruent sides and the non-congruent side, that third side there. As the angle gets larger, the third side gets longer. Right? Questions? Okay. Anthony, that's enough of that. Thank you.
Sounds cool though.
Who knows? One of those buttons might just say, "You've been pipped!" You want me to press that one?
Yellow one.
Okay.
Do you have a Ronaldo one like Mr. Wilson has?
Summarizing the Hinge theorem and the converse of the Hinge theorem, the Hinge theorem basically says, well, no, I'll say mine. When there are 2 congruent sides.
What? I thought we already wrote
That was the relationship of just the angle on that third side from the above example. This is the official Hinge theorem.
So this
When-
is supposed to go up there.
Yeah, that's how I did too, D.
No, it doesn't matter. I mean, it's the same thing. If you get the gist of it, you don't have to put it exactly word for word. But basically, when there are two congruent sides of two triangles, the size of the included angle, I should say that the measure of the included angle is connected to the length of the non-congruent side. I'm laughing because I don't think I could have worded this any more horribly than I did there. Okay? Nor write this anymore. What was I thinking? When there are two congruent sides of two triangles, the measure of the included angle is connected to the length of the non-congruent side. Basically, summarizing what we wrote up above, was that the larger that included angle, the longer the third side. Okay? The longer the side, the larger the included angle. It essentially is. This is the official wording of it, though. So, yes.
You just made it.
I did just make it up.
Yeah.
I did. I could have used much better wording here and much better spacing in my writing, but you know, oh well.
The guy who created the theorem just made it up.
Yes.
I need to run another test. Would you mind?
Yeah. You have something I can write down on?
We have like 4 tests running at the same time, and nobody remembers their password. And I know you've given it to me before, but I forgot. Why am I wrapped up in red?
My 7th graders
Can't
ransacked my
see
room.
my
I know.
You clicked it, that's why.
This is Dawson, that's a tricky tattoo.
What?
I'll tell you about it sometime.
She got that?
Okay. So the application of this. Sit flat, please. The application of this, let's look at this first diagram here. We are asked to compare the length of AD to the length of CD, right? AD is right here, and CD is right here,
It's the midpoint.
okay? And without, a whole lot of information here, the eye test, they look pretty close. Someone said that they thought it was the midpoint,
It is.
okay?
No.
Wait, which one was that? I didn't see it.
Right.
But
That was-
with the Hinge theorem, we can take a look at the information that we know and make a decision. We've got one pair of congruent sides marked, and because of the reflexive property, we know we have I'll use blue. We know we have a second pair of congruent sides here. So because we've got that included angle, that 36 and 32, what can you say about the length of AD compared to CD?
It's bigger.
Which one's larger? Catherine, you have an answer?
I have the answer.
Yeah.
AD,
AD is larger than CD. Why?
because 36 is larger than 30.
Exactly. Because of the Hinge theorem and knowing that 36 is greater than 32, we know that AD has to be greater than CD. Okay? That measure of that included angle is directly connected to the measure of that opposite side, the non-congruent side. Okay? Damien,
How do I prove that though?
prove what?
We're
See,
not gonna prove
the beauty of the Hinge theorem and any theorem that we had talked about here is that we don't have to prove it because someone already did.
Yeah, but
So that
Right?
Then why do we have to do the lessons before?
Because you need to know how to arguably
yeah, but if we never use
logically argue something.
it, but if we never use it, then it's kind of useless.
The Hinge theorem's useless?
No. But like proving.
No, I hope that you use deductive reasoning in the future, Damien. Your life
Oh
will
yeah, I'll
be
just
Remember what that is.
rather interesting if you don't. The next one. 3, 2, 1, you are quiet. Again, we have 2 pairs of congruent sides marked. And we're given the measure of 2 angles, and we are asked to compare the length of TR to the length of UR. What can you tell me about the length of TR compared to UR? What inequality symbol goes in that spot? Brandon.
TR is less than UR.
TR is less than UR because 22 is less than 24, right?
Mrs. Ressler, could you please come to the school office? Ressler at the office,
Second grade
please. Thank you.
My sister.
Okay. The next one, we're looking to compare the measures of angle 1 and angle 2. So here's where we can use the side lengths and angle measures to conclude information about angles. We've got our two congruent sides, and this is a requirement. We have to have those two congruent sides there. Just like when you open a door, the doorway itself doesn't change the length. The door itself doesn't get wider as you open it. The opening gets wider because the angle does, right? So these two congruent sides are requirements, and we're looking to compare angle 1 with angle 2. What can you tell me? What inequality goes in between angle 1 and angle 2? Kyle.
Angle 1 is less than angle 2.
Angle 1 is going to be less than angle 2 because the opposite side from angle 1, Anthony, the opposite side from angle 1, 13, is less than the opposite side from angle 2, 14. Joey. Question on this one first?
No.
Okay, Joey. Next one. We're looking to compare angle 1 and angle 2. What do you think?
They're equal
Why do you say that?
because it's side, side, side.
They are congruent triangles. We have those two marked sides, and because of the reflexive property, we also get the third. By using the Hinge theorem, because the side opposite angle 2 and the side opposite angle 1 is the same side, obviously it's equal to itself, congruent to itself, because of side, side, side. The Hinge theorem also proves that. Okay? Again, we're building this toolbox, right? If you forgot all about side, 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 this is a situation where you could use the Hinge theorem instead to prove that that third side is congruent to itself. If you forgot the reflexive property, the Hinge theorem also works. Damien.
You don't really need side, side, side.
That's what I just said. Thank you for
Yeah,
repeating.
you can just draw a line and there you have it.
There you have it.
Yeah.
Okay? Other questions on this? Damien, please be respectful.
She just told me to stop talking.
And you said shut up. That's a little bit worse.
Okay. Wait.
A little bit worse. Liesel.
So if you have to like retake for proofs, could I use that theorem?
If you knew that you already had the two congruent sides and you wanted to get that third side, you could. You know, the nice part about retakes in geometry is that as you learn more, you have more options, more tools to do the stuff that we've done previously.
So we can
As you
just do
certainly
proofs
can.
last, so we have all the.
Two hikers start at the visitor center. Okay? Here's our visitor center. It's a little house.
Twice today.
Sorry.
Is there trees
What?
behind it?
Kylie, Catherine, turn around, please. No, turn around. The first hiker walks 6 miles due west, turns 20 degrees towards south, and then walks 2.5 miles. So let's draw this path of the first hiker. Okay, starts out going 6 miles west. Turns 20 degrees toward south.
That's not 6 miles.
Estimation. And then walks 2.5 miles. Now, this is a 20-degree turn here. If he were to extend going forward, this would be 20 degrees, which makes what angle is that there? Yeah, 160, right? So a 20-degree turn. If the hiker had continued going straight, there would be no turn. But at a 20-degree turn, it makes this angle 20 degrees and that 160.
I don't
Okay. The second hiker walks 6 miles due east, so their horizontal travels are the same. Turns 60 degrees towards north and walks 2.5 miles. Okay. So if he had continued going forward, there'd be no turn. But a 60-degree turn towards north would make this angle here.
60 degrees.
Nope.
Oh,
They're not. It's a freehand sketch. Okay, 120. And the question is, This is 2.5 here. And the question is, which hiker is closer to the visitor center? Okay, so what we're looking at is this hiker is now here, going back to the visitor center. This hiker is now here, going back to the visitor center. That's the path that they would take to go directly there. Which hiker is closer, and how do you know? Anthony.
First hiker,
Why?
because it looks closer.
You can eyeball it.
You could eyeball it.
Second one.
Why?
Wait, which button did you click?
Because it's a
What's
shorter
the
angle.
second one?
Because of smaller angle. We know that the second hiker is closer because using the Hinge theorem, because these, hey folks, quiet please. Because these two sides are congruent, they're both 6 miles. Because these two sides are congruent, they're both 2.5 miles. We can look at that included angle, that 120 compared to the 160, and because that 120 is smaller, it means that this third side is shorter than the other one. Therefore, the second hiker is closer to the visitor center. Okay? Damien.
And you can get there faster because one's going downhill and one's going uphill.
Yup.
So
Exactly.
We do not know the topography of this particular terrain,
it's going up
but
and
perhaps.
going back.
Sit flat, please. I don't want an injury. Alex, you have your hand up?
Wouldn't it be the same because they walked the same and they turned around?
They did not, because
Where
the
does it
key
say
here is the angle at which they turn.
And one's going down and one's going up.
Okay? They walk the same distance, but depending on which angle they turn, that's going to depend on how far away they are from it. Yeah.
So technically for
Yeah.
this, we can just choose the smaller number that they give in like the word problem.
Well, it depends on what the question is. If the question was who's further from the center, then you want to take the larger one, right?
Yeah.
But yes, that you got the gist of it. That connection between the angle measure and the sideline, Catherine, is definitely present. Okay? All right. No homework for tomorrow other than go back in for homework check. Test on Friday. Practice test tomorrow. That is how you math.
Subscribe.